Miss, we can't hear you, Miss.
There we go. So we went horizontally from left to right. Now what we're going to go ahead and do is we're going to go ahead and add vertically up and down. It's up to you whether you want to do it left to right or up and down, whatever your preference is, but I'm going to show you how to do both. Okay. So same expressions, but this time I'm adding up and down. So basically I'm adding this expression. I'm just going to move it down here. Plus this expression. Right, so I'm adding those together and I'm doing it horizontally, so up and down. So this would be me adding those together. However, what I want to do is I want to make this easier myself. And the way that I can make this easier for myself is I want to make sure that whenever I look at these two expressions, they have the same variables downward. So you see how these don't really match? And so I want to go ahead, I'm going to rearrange this equation right here just to make it easier for me to go ahead and do that addition. So it's going to be the same thing, but I'm just going to go ahead and move the 2x cubed to the front. I'm going to move the 6x to the middle and then keep my 8 where it is. This just makes it easier for me to go ahead and add, but it's the same thing. I'm just moving these things around. So this got moved here and this got moved here. But again, it's the same expression. I'm not really changing anything. So now let me go ahead and rewrite that. Bottom expression. Negative 2x squared plus 6x plus 8. And what you'll notice what I did there by going ahead and rearranging it is now it's going to be easier for me to add my like terms downward. Right? Because I have all my similar terms right next to each other. And so now I can go ahead and just add. So the way you add, here you do not have anything else that's x cubed, so you're just going to drop that down. Here you do have like terms. You have x squared here, x squared here, so you're just adding those terms. You don't have to add the x squared. All you have to do is add the variables in front. So 3 plus negative 2. 3 plus negative 2 is just a positive 1, so I'm just going to put x squared. It would look like basically like that. A positive 1x squared. Okay. Here I also have like terms. 4x plus 6x. Those are like terms because they both only have x. Again, I don't have to add the x's. All I have to do is add those variables in the front. So 4 plus 6, 10x. And then in here I have my whole numbers. I have a negative 5 plus a positive 8. So negative 5 plus positive 8 is 3. And then all I have to do is drop down my symbols. So plus, 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 right? Because I'm adding those together. And so therefore, I get my resulting expression, which is what happens when I add those two polynomials together. So as you'll see, we did get the same expression twice. We get x cubed plus x squared plus 10x plus 3. X cubed plus x squared plus 10x plus 3. Right? Those two are the same. So whether or not you want to add vertically or you want to add horizontally, it's totally up to you. But these are the steps to do it vertically and horizontally. Okay, basically what you're doing whenever you're adding polynomials is you're just combining like terms. Okay, questions about adding? Okay, now we're going to get into subtracting. Oh, actually, we're going to look at these different principles for adding, and then we'll get into subtracting. So we have different properties for additions of polynomials. We have the closure property, which basically says the sum of two polynomials is a polynomial. So if I add two polynomials together, for example, if I added these two together, what I would get is a resulting polynomial. No one second. Okay. So how do I add these? I can do it horizontally or I can do it vertically. I'm just going to do it horizontally here. I have a 4x, I have a 3x, and I have two whole numbers. So I'm going to combine those like terms. 4x plus 3x, so 4 plus 3, 7x. 5 plus 2, 7. Put that plus sign right there. And there's my resulting polynomial. What my closure property tells me is that if I have two polynomials being added together, polynomials are basically just equations that have more than one variable. So this one has a 4x and a whole number, that's more than one variable. This one has 3x and a whole number, so that's more than one variable. So I have two polynomials added together, and my resulting equation will be a polynomial as well. I have 7x plus, I have a variable with an x, and then I have a whole number as well. Okay, so that is the closure property. The next one is the commutative property. The commutative property basically tells me the order in which you add things together do not matter. You'll get the same answer. So for example, I have this expression right here. And the way I added it was I put the 4x in the front and the 3x in the back. Well, if I were to rewrite that where I had 3x in the front, where you can see that I've switched those two. What this is telling me is that basically my resulting polynomial wouldn't change, right? I'm still adding 3x plus 4x, which is still 7x. And I'm still adding 2 plus 5, which is still 7. And so those resulting polynomials are the same. And so what this is telling me is that addition follows the commutative property, which tells me that the order that you add things doesn't really matter. You still get the same answer. Okay, so the two properties that we see whenever we do addition is the closure property and the commutative property. Okay, so now we're going to get into subtraction. Okay, I keep saying we're going to get into subtraction. One more thing. The other property that is followed by addition is the additive inverse property. This basically says subtracting a polynomial is equivalent to adding the additive inverse of the polynomial. So what is the additive inverse of, for example, 6x minus 2x cubed plus 8? Okay, well, here we have that polynomial. I can write that here. 6x minus 2x cubed plus 8. The additive inverse basically just changes the sign of everything. So here we have an imaginary positive sign. Here we have a negative sign. Here we have that positive sign. Basically, whenever you do the additive inverse, you're switching it. So we had a positive 6x. So now we're going to have a negative 6x. We have a negative 2x squared. So now we have a positive 2x squared. We have a positive 8. And so now we have a negative 8. So the additive inverse is basically just changing those signs. So yeah, to find the additive inverse of a polynomial, change the signs of each equation. All right, so now we'll go ahead and get into subtraction finally. So again, much like addition, whenever you work with subtraction, you can do it horizontally or you can do it vertically, whatever your preference is. I will go ahead and go through both. But again, it's up to your preference. So subtract x cubed plus 3x squared plus 4x minus 5 from I'll do 6x minus 2x cubed plus 8, right? So I'm subtracting those two expressions from each other. Well, I want to do the first thing that I did whenever I did addition. I want to go ahead and write that expression, but I'm going to go ahead and do a big bracket around both of my expressions. So this is my first expression. I'm moving that down. And I'm subtracting that first expression from my second expression. So I'm just basically writing that I'm taking those two polynomials and subtracting them from each other. Okay. So there is me subtracting both of those two expressions from each other. Okay. Now, the easiest way to go ahead and subtract is to go ahead and write the subtraction as an addition of the additive inverse. What that basically means is the easiest way to go ahead and subtract these two things is to go ahead and write the expressions where you're adding them, but you're adding the additive inverse. So here I'm going to drop this down. Instead of subtracting, I'm going to go ahead and add. And what I'm going to add that expression to is the additive inverse, which means I'm going to go ahead and change the signs of this expression right here. So instead of a positive 6x, I'm going to do a negative 6x. Instead of a negative 2x, I'm going to do a positive 2x squared. And instead of a positive 8, I'm going to do a negative 8. Okay, so I went ahead and added the additive inverse. Remember the additive inverse? All you're doing is you're switching those signs. So switching all the signs. Okay, so my first step in subtracting is writing out that expression. Then what I want to go ahead and do is add the first expression to my additive inverse in my second expression. Okay, now what I'm going to go ahead and do is do the same thing that I did whenever I added these expressions up here. I'm grouping like terms and then combining them. So grouping like terms means putting together terms that have similar expressions. So I have an x squared, I have an x squared, I have a 4x, I have oh, this isn't supposed to be x squared. That's why. Hold on, guys. Yeah, because it was originally 6x, not 6x squared. Okay, so now I'm combining 3x squared plus 2x squared, 4x plus negative 6x, negative 5 plus negative 8. Okay, so now I'm grouping together my like terms, and I basically just group them together in an addition expression. So I don't have anything that pairs with x cubed, so I'm just dropping that down. Plus, I do have something that groups together 3x squared plus 2x squared, so I can put that together. 3x squared plus 2x squared plus, right, because I'm adding. Now I can go ahead and put together my other grouping of expressions. So 4x plus negative 6x, right, because there's a negative in front of it, and I want to make sure I include that. Plus, now my whole numbers, negative 5 plus negative 8. Okay, so there I've gone ahead and I've grouped all my different like terms into an addition expression. So I'm obviously adding these together now, because that's what this symbol tells me to do. And so now I can go ahead and just add downwards. So x cubed just drops down. 3x squared plus 2x squared is just 5x squared. 4x plus negative 2x is negative 2x. Or 4x plus negative 6x is negative 2x. Negative 5 plus negative 8 is negative 13. Oops. Now I'm just putting those plus signs. And there I get my expression, which is the result of me subtracting those two polynomials together. Okay, so whenever you're working with subtraction, the first thing you want to do is you want to go ahead and write that expression out. So this variable minus this variable, subtraction. Then the easiest way to go ahead and subtract these two expressions together is to add the additive inverse. So I'm going to switch the signs here. And now I'm adding, and I'm doing the additive inverse, so I need to switch all these different signs out. I'm just flipping the signs. And now I have an expression which I can add together. I'm grouping those like terms like you see me doing there with the highlighter, and then dropping those like terms down so that I can go ahead and actually add them, and then that gives me my resulting expression. Okay, questions about how to subtract horizontally? Okay, so we can also do the same thing, but we can go ahead and subtract vertically. So if I took the same expression, and again, it's up to you which way you want to subtract. You can do it horizontally or you can do it vertically. Totally depends on your preference. You'll end up getting the same answer. So I'm subtracting that first polynomial from that second polynomial. Okay, so I'm going to go ahead and move this down. And now I'm just subtracting horizontally. So I'm going to subtract up and downwards. Now remember what I did whenever I did the addition. I went ahead and rearranged that expression so that it's easier for me to subtract downwards. I'm going to do the same thing here. It's going to be the same expression, but I just went ahead and switched things around so that it's easier to work with. Okay, so as you can see, it makes it easier to work with. Now it's easier for me to group my like terms. Here I have all my x squared. Here I have all my x's. And here I have all my whole numbers. So now it's easier for me to just subtract downwards. So this one, all you want to do is you want to go ahead and do the same thing. So the easiest way to do is to write the subtraction as an addition of the additive inverse. So I'm going to change this to it, but I'll do it in red. I'm going to change this to an addition, and then I'm going to change these signs. So this becomes a positive, this becomes a negative, and this becomes a negative. Okay, so now I'm adding the additive inverse. So that just means changing the signs to the bottom ones. Now I have this expression, and so now I can just go ahead and add downwards. So x cubed, there's nothing to add to x cubed, so I'm just dropping it down. Now I have 3x plus 2x, which is 5x. Now I have 4x plus negative 6x, negative 2x. Now I have negative 5 plus negative 8, negative 13. And there I get my expression. And what you see is that those two are the same. So it's up to you which one you want to go ahead and choose to work with. Okay, so whenever you're going ahead and subtracting, you want to go ahead and add the additive inverse because that makes it easier for you to go ahead and solve the problem because all you're just doing is adding those like terms. Okay. As far as the properties that subtraction follow, the subtraction follows the closure property. So remember the closure property basically says the difference of two polynomials is a polynomial. So the other one said the addition of two polynomials is a polynomial. This closure property would tell me the difference of two polynomials is a polynomial. So for example, if I wanted to take this expression minus this expression, again, the easiest thing to do is to go ahead and add my additive inverse. So that means changing these signs. That's, yeah, changing those signs. And then I can go ahead and add my like terms. 5x cubed plus 3x cubed, 4x plus negative 2x. 5x cubed plus negative 3x cubed is negative 2x cubed. For x plus negative 2x is just a positive 2x. And so there I have my resulting expression. Okay, and so basically what this is saying is if you subtract two polynomials from each other, your resulting expression will also be a polynomial. Okay. The commutative property doesn't apply for subtraction, and the associative property do not apply to subtraction. So only the closure property applies to subtraction. Okay, so basically what we learned today is you can add polynomials horizontally or vertically, or you can subtract polynomials horizontally or vertically. And whenever you go ahead and subtract polynomials, what you actually want to go ahead and do is you want to rearrange the equation where you are adding the additive inverse of a polynomial. So basically the additive inverse is just switching those signs. The set of polynomials is closed under additive and subtraction. So we use the closure property for both addition and subtraction. And polynomials follow the commutative and associative property for addition, but they don't do so for subtraction. Okay, these are the different types of problems you might encounter. You may be asked to add two or more polynomials horizontally or vertically. You may be asked to determine the additive inverse of the polynomial, which is basically taking the opposite or changing the sign of each term. Or you may be asked to subtract two polynomials horizontally or vertically. Okay, questions?
No, ma'am.
So, questions? So
No,
tomorrow,
ma'am.
whenever we go over practice problems, basically we're just going to go over how to add or subtract polynomials from each other. Okay. All right, so we'll go through that tomorrow. If there's no other questions today, you guys may log off, and I will see you guys tomorrow. Bye, guys.
Bye, Miss.
Bye.